Alright, welcome back everybody. In this video, we're going to talk about information from section 6.10 of AP Calculus, integrating functions using long division and completing the square. This is our second video on the subject. In the first video, we went over examples of integrating functions using long division, and this video is going to focus on the second technique, completing the square. So, technique number 2, completing the square. This is used when we have a quadratic expression in the denominator of a fraction. Like we do here, we have a quadratic expression in the denominator. And most of the time when we use this, the numerator of the fraction is constant. Doesn't necessarily have to be, but a lot of times it is. And also, usually, this technique results in an integral that contains an inverse trig function. So like we're going to end up with something that becomes an arcsine or an arctangent or something along those lines, or an arcsecant, or something along those lines. So the first thing for us to do is to simplify this expression by completing the square, changing it into something else. Now, if you remember how to complete the square, when we have an expression like this one, x squared plus 8x plus 17, what we want to do is we want to turn this into an expression of this form, x plus something, well, because this is a plus sign, x plus something else. And the way we complete the square is we figure out what the value of this number is going to be, so that when I expand this squared expression, we're going to have this number of x's. And so the way we figure out this number is by taking the quote-unquote b value of the quadratic expression and dividing it by 2. And so in order to complete the square here, we want this to be x plus 4, the quantity squared, plus something. Now if we expand x plus 4, the quantity squared, we get x squared plus 8x plus 16, which means that the other number that we need to add outside of here, in order to get it to be equal to our original expression, we need to add a positive 1. And so, this expression can be rewritten as the integral, and I'm going to change the order here, of 1 plus the quantity x plus 4 quantity squared with respect to x. Okay, so now I've rewritten the denominator by completing the square. From here, this becomes a problem in substitution. I'm going to replace this quantity that's inside the parentheses with a u, and then du is equal to dx. And by making this replacement, this becomes the integral of 1 over 1 plus u squared du, which hopefully by this time you recognize that this is the arctangent of u is the integral of this. And so that's going to become the arctangent of u plus a constant. We bring our u back, which is x plus 4. And boom, there is our integral of 1 over the quantity x squared plus 8x plus 17 dx. Alright. Let's go ahead and look at one more example here. Part B, we're going to take the integral of 1 over the square root of negative x squared plus 6x minus 8. Alright, so we want to complete the square with negative x squared plus 6x minus 8. And the first thing I'm going to do is I'm going to factor out a negative 1 so that my leading coefficient is positive. Okay, and we would like this expression to turn into x minus 3, the quantity squared, plus some unknown, currently unknown value. And so we've got negative, and when we expand this out, that's x squared minus 6x plus 9. And so the value we want to add in here is negative 1. Alright, now I'm going to bring this negative 1 outside, and when we take the opposite of that, it becomes a positive 1. And so I can rewrite this whole expression like this. And so I can replace what's inside this radical with the expression 1 minus the quantity x minus 3 quantity squared. So this is equal to the integral of 1 over the square root of 1 minus the quantity x minus 3 quantity squared dx. Okay. And now again we can use a substitution, and we get we use u equals x minus 3, so du is equal to dx, and this turns into the integral of du over the square root of 1 minus u squared. And so taking the antiderivative of this is going to be the arc sine of u plus a constant. And then I bring my u back. And boom, there's my integral. All right, that's it for this video. It's up to you now to do some problems, practicing using long division and completing the square in order to integrate and kind of get this concept under your belt. And then we're going to move on. For those of you who are in AB, this is the last video of the unit. I don't have a video for section 6.14 because there's no examples in that section for me to explain in my lesson for that. For those of you in BC, we're going to move on to integration using integration by parts, partial fractions, and evaluating improper integrals in our next series of several videos. Okay? Have a great rest of your day, everybody, and we'll see you next time. Bye-bye.